So this is just a first look at Spyder. I wanted to show you this because this is what I use to write all my programs. You can download Spyder directly. That's Spyder. But I run mine through Anaconda, and I use Anaconda as a package manager for everything that I do. Couple of things. Notice the toolbar in the top. You will want to use a lot of those features. You will especially want to break your program into cells so that you can run individual pieces to find out if anything is amiss at any point. You'd break those into cells by anything that starts with a hashtag is a comment. You can also put in comments in line, like I declare a variable right here and then comment as to what it is right next to it. You define cells by a hashtag and 2% signs, right? And then the next cell starts at this hashtag and 2% signs, right? So I have 1, 2, 3, 4, 5 cells in this program. It's called simple math. Right, and there's no magic to it. I'm just going to show you how to do some math and show you some things that Spyder will let you do. Down here in the lower right-hand corner, where it says MEM, that's the amount of memory that you are using. Now you'll notice that I am up to anywhere between 58 and 60% memory use on my box at the moment. I've got a fair number of things running. I've got the screen recording going on. I've got Anaconda running. I've got Python running and a few other things in the background. Where you will want to keep an eye on this number, right? Because as this creeps closer to the 80s, you, especially if you're running a Windows box, will be doing a lot of use of your swap area on your disk. And you will want to be very, very careful of that because it will slow your machine down and could ultimately cause it to crash. When we do image manipulation and you import a large JPEG or PNG file, you will have to watch that number. And anything that you write and any image file that you manipulate, you will want to make certain that this stays somewhere 70 or under. If at all possible, which might mean you have to close some things out. Now, just to get you started, if I just hit that green triangle, right, that will run the entire program at one shot, which is not bad. That's what you normally want to do. But the thing next to it, which is run current cell, you click in the cell that you want to run and just run that. Notice that it tells you that it's just running that cell, right, and does whatever you tell it. Well, here it's a bunch of comments, right, and it loads this get size of command from the system utilities that are available to Python, so that I can actually ask for the size of in bytes, how much memory is being used by a particular variable, which is important when you are trying to maximize your programs or make certain that you are not writing something which is using too much space. The next cell, if I just run that, and then I come over here and notice where it says Variable Explorer. If I click in Variable Explorer, now you notice that I am getting all of my variables listed. Notice they are not in the order in which they are declared. They are listed alphabetically, which is a little weird. You would assume that they would be listed in the order in which they are declared. On the other hand, once you get used to it, it's actually very, very helpful because what that means is it's easy to find the variable you just declared, and what is in it. Cool part is that it gives you the name of the variable, the type of the variable. It's telling you what it is. Right? It's telling you what size it is, right? And it's telling you what is stored in it. So even if you don't have a print statement, like down here on the right hand side, that's where all of your output print statements will happen. Right? There's nothing to print yet. We haven't gotten to this module down here in the lower left, which says print the answer and a bunch of other information. Now, here I'm just declaring the variables, but at least I can see what it is and what it has in it. And that's important as far as your debugging goes. If I now click in the next module and or cell and I just run that one, notice that it now adds, right? And I'm not that inventive. R stands for results, right? And I just do a bunch of results, 17 different computations to see what's going to happen to the thing. I notice that it's really there to show me, if I mix and match. If I mix a float with an integer, what do I get? If I mix an integer with a complex, what do I get for a particular result? Right. And I don't have to print anything yet. I could just scan through here and it tells me my values. Right. Notice R12 is interesting. Right, because I am doing modulus math. Right, so I am taking I1 and dividing by I2. Right, the result is an integer. Right, but it gives me 0. You should know why it gives you 0 for that type of math. All right, R15. Again, you should take a look at the comment. I am taking a float and dividing by essentially an integer. Right? And R15 tells me I get a float out of that. Right? Not, modulus math and it's a float. That's, kind of funky. That should not be happening. Come down here, and this is actually, if you just ran the program, what you would get as output. All right, this is going to be all the results. All right, now notice the the solution for R2 is, and it gives you the answer. It tells you the actual memory address for it, and it tells you what class it is. It is a floating point value. It also tells you the number of bytes of memory which is being used to store it, which is 24. This is 32-bit math. Notice down here when you have a complex number, it takes all 32 bits. 32 bytes, I'm sorry, of math. And then, of course, the last. And you run that last cell. And that last one is interesting. You should try and figure out why it's reporting it as 0.0 instead of just 0. But that just gives you some fundamentals on how to use Spyder, right? How to declare cells. Once you are done, if you want this to still be a comment, you can just take out the 2% signs and it remains just a regular comment. It's not a cell comment. Otherwise, even if you just saved this program as is, right, and then shoved it in, to the Python interpreter and asked it to run the program, it would do it, right, and it would do it without any problems. It knows to ignore the hashtag %%, right? That's just a comment, right? It's a feature of Spyder that the hashtag %% defines a cell, right, which then you can run individually to help debug the program. Right, so you don't have to run it line by line by line. You can run it chunk by chunk. So then we will move on to the next section.